Hey guys, Russ here coming with a fantastic chemistry video, and today we're going to talk about alcohol. Alcohol, you know it, you love it, you drink it, makes you feel 10 foot tall and bulletproof, makes you feel amazing. Alcohol. Alcohol has strong similarities to water. How so? Well, water, as you all know, is H2O. A couple of hydrogens on either side of the water and a couple of lone pairs. It's sp3 hybridized. So let's draw those orbitals just to see. We all know that the hydrogens are attached with sp3 orbitals. There we go, a couple of hydrogens. And the lone pairs are also in sp3 type orbitals. This one will be a little heavy because it's coming towards us. And there should be one dotted like that going away from us. And that's water. Water has an sp3 structure. The simplest alcohol, methanol, the central oxygen has a hydrogen on one side, and we'll just draw the CH3 group on another. Again, the oxygen has two lone pairs, just like that. So this is a simple Lewis structure of methanol. Now this oxygen is also sp3. Which same as water, right? Now, the oxygen will be sigma bonded to the carbon. So those are going to overlap. And there'll be the hydrogens on here. I'm not overly interested in the hydrogen here, or the carbon hybridization. I'm more concerned with focusing on the oxygen, but the carbon is also sp3, which you could draw. And if not, there's other videos in the series that you could watch to show you how to draw carbon sp3. It's very simple. The hydrogen on the right-hand side, just like in water, is also in an sp3 orbital. And of course, the lone pair, this will be heavy because it's coming towards us now. And this lone pair here is going away from us. So it's very similar to water in that you can see they bond angles are similar but not the same. Two lone pairs, sp3 hybridized, very, very similar. I think everyone can see that, but there are substantial differences. Now, one thing to talk about real quick, this is kind of interesting to think about. The only difference between this structure and this structure is the presence of this methyl, CH3. The only difference. This absolutely required for life as we know it. This will kill humans in small doses. Very, very small change. It's a CH3. Replace a hydrogen for a CH3. Required for life. Deadly to humans in small doses. Pretty cool, huh? Anyway, so right now we're going to move on to the next topic. I'll see you there. All right, so now we're going to talk about the classifications of alcohols. They come in primary, secondary, and tertiary examples. So let's start by just drawing a molecule of ethane. So here's ethane in all of its structural glory. Very simple little molecule. Now, to make an alcohol, we have to attach a hydroxyl or an OH to one of the carbons. Take off one of the hydrogens, replace it with an OH. No problem. So before I do that, if I were to ask you right now, is that carbon primary, secondary, or tertiary, you would all say primary. If you don't know why, there's other videos you can refer back to or refer back in your notes to find out why these are called primary carbons. So now, let's just take off this hydrogen right here. Let's just erase it. And let's put that OH on there. Now, because this carbon, we've already identified it as primary. Now, it has one other carbon attached to it, which is why it's primary. The OH is on a primary carbon. So this is referred to as a primary alcohol. Very good. No problem at all. Now, let's draw propane. Same as before, we're going to put the OH on some carbon. Now, this example, I want to draw a secondary carbon. I've already drawn a primary alcohol. I want to draw a secondary alcohol. So if I were to ask you, is that carbon primary, secondary, tertiary? You would all say, hopefully, primary. You would also say, that one is primary. So if I put an OH on here or on here, that'll make a primary alcohol. But I want to make a secondary one. So that carbon is secondary. It has two other carbons attached to it, so it's secondary. So erase one of those hydrogens, just like that. Put an OH there, and that's a secondary alcohol. Secondary alcohol. Let's try tertiary. Now, to draw a tertiary, you need to have a tertiary carbon. So now, if I were to ask you what is the degree of this one, it's primary, secondary, tertiary, you would say primary. For that one, you would also say primary, and that one is primary. This one, however, is tertiary. So if I were to put an alcohol here, OH here, here, or here, that would be primary alcohol again. If I put it here, however, that's tertiary. So let's rub out that hydrogen. Put the OH there. That is tertiary alcohol. Because the OH is on the tertiary carbon. So it's a tertiary alcohol. Just like tertiary chlorides or tertiary or primary bromides or whatever, same thing with alcohols. The OH has to be on the tertiary carbon for the alcohol to be considered tertiary. Now there's also aromatic alcohols where the let's do it that way. Where the OH is attached directly to a aromatic ring. These are called aromatic alcohols. So they're classified as the aromatics. This particular one is called phenol, but that's the actual name of it. This is considered, the classification is aromatic alcohol. All right? And that's how you classify alcohols.